Okay, now before we move on, I'm just going to talk you through something very basic. What is an image? And you must be wondering that this question is a no-brainer. In front of you is an image, and as you can see, it's a color image of a cat. So we can just see the image. This is a cat, it's got greenish eyes, it's a tabby cat, and it's sitting on a sofa. So at an instinctive level, we all know what an image is. That is not the point. Now the thing is that when we work with image processing, it's important that we know the scientific aspects of an image, and I'm just going to talk you through that. An image basically comprises of pixels, and pixels are subsamples of an image. So if this is my image, say assuming the image of a cat, then it's going to comprise of subunits like this, and these different subunits, they go to make up a pixel like this. So this is a pixel. Now, a lot of the image processing, the scientific underpinnings of image processing, they hark back to the era of 32-bit processors. And in order to render the different colors, so as you can see, this is a color image with different colors and so on, that is dependent on something known as BPP, which is bits per pixel. And all of these images that you see are RGB rendering. So in order to render color images on our screen, most computers, they make computer monitors or LCDs, they make use of the RGB scheme, which stands, as you can imagine, as the name suggests, R stands for red, green for green, and blue for blue. Well, B for blue. So again, now, but we just don't have three colors in the image. As you can see, the cat itself, it's a brownish cat, and you can see that. Now, where does this come from? The different color schemes, they come from bits per pixel, and bits per pixel decides how many colors can be rendered on the screen. And usually, in most cases, and that's how the binary mathematics works, I'm not going to go into this, we can have a total of 256 colors which can be used to render our images. So we have 256 colors, and therefore in most cases, for most of the data we work with, the pixel values, they vary from 0 to 255. So, and the different combinations of 0 to 255, they go into defining the different colors which ultimately can be used to render our images. So if all of this is theory and it sounds a bit too scientific and theoretical to you, just remember that we only have 256 colors that we have access to in order to render our RGB or color images. And the pixel values, the values of the different pixels, they vary from 0 to 255. So these are the different pixels. Now this is another pixel, and their values are going to vary from 0 to 255, and these different combinations will ultimately give us images like these. And these numerical quantities that I've discussed, they are going to come in handy as we start reading in the images and start rendering them and start playing around with them. And just remember that the color images that you mostly see on screen are RGB renderings.